All right, one thing to note is that not all samples are created equal. Some give you better results than others. If someone were permitted to pick and choose exactly which cases were included in a sample, it is entirely possible that the sample could be skewed to that person's interest. This introduces bias into the sample, which calculates statistics in such a way that it's systematically different from the population parameter being estimated. A biased sample causes problems because any statistic computed from that sample has the potential to be consistently erroneous. One of the most famous examples came in the 1936 presidential election between Franklin Roosevelt and Alf Landon. What's notable about that election is the Literary Digest poll, which was based on over 2 million returned postcards, actually closer around 2.4 million. In its October 31st issue, Landon was predicted to easily win with 370 electoral votes and 57% of the popular vote. And if you're not familiar with President Landon, it's because there is no President Landon. He didn't win 370 votes. He didn't win 10. He actually finished up with 8 electoral votes. And in fact, his electoral vote total of 8 is a tie for the record low for a major party nominee since the current U.S. two-party system began in the 1850s. If you're not familiar with the Literary Digest, by the way, it was completely discredited because of this poll and was soon discontinued. So, we have this question to ask now is, why did the Literary Digest fail? There's two main reasons, and both have to do with bias. The first major problem was the poll was in the selection process for the names on the mailing list, which were taken from telephone directories, club membership lists, lists of magazine subscribers, and so forth. So such a list is guaranteed to be slanted toward the middle and upper class voters, and by default to exclude lower income voters. So in other words, there's a big part of the population that was not included in this study. The second problem was the Literary Digest poll was actually sent out 10 million postcards, whose names were on the mailing list, but only 2.4 million responded. Thus, the size of the sample is only about 1/4 of what was originally intended. And basically, those who respond generally have a different opinion than those who don't. So in general, there are 3 common types of bias that might occur in a sample. Selection bias, that's basically the method for selection makes the sample unrepresentative of the population. That is, there's going to be a part of your population that was not included or was under included. A non-response bias is that a sample is chosen, but for whatever reason cannot or will not respond. And then a response bias is that participants in a survey provide incorrect information, whether intentionally or unintentionally. It could be that the person just did not understand the question, so they responded differently, or maybe they just flat out lied. Okay, let's indicate the potential bias. Indicate whether the potential bias is a selection bias, a non-response bias, or response bias. Okay, a survey question asked of unmarried men, what is the most important feature you consider when deciding whether to date somebody? The results were found to depend on whether the interviewer was male or female. So, from the information we have, we can't really see a selection bias. Our population is unmarried men. There may be a selection bias, but it's not apparent in that paragraph. Non-response bias, don't see that anyone did not respond. Maybe, but it's not shown there. What we have here is a response bias. That is, if your response depends on whether the interviewer is male or female, or for that matter, if your response depends on the interviewer in any way, that's a response bias. So this would be a response bias since the response depends on the interviewer. You need to conduct a study of longevity for people who were born in the decade following the end of World War II in 1945. If you were to visit graveyards and use only the birth-death dates given on the tombstones, would you get good results? Well, if you're trying to do a study on longevity, how long people live, and you completely ignore the people who are still alive, I would say you're going to get bad results. So you likely will not get good results. If you're studying how long people live and you're ignoring those who are still alive, your results are going to be a lot lower than they should be. If you had to do it again, would you have children? This is the question that advice columnist Ann Landers asked her readers back in 1976 in Good Housekeeping magazine. It turned out that nearly 70% of the 10,000 responses she received were no. Now, this was pretty surprising to lots of people, so there were actually 2 professional polls were done, including one by Newsday that found that 91% of randomly chosen respondents would have said yes. So her survey said 70% no. A professional survey had 91% yes. That's a pretty big difference. So in terms of why there's this contradiction, a lot of it has to do with how it was sampled. Ann Landers' survey was basically she asked her readers to respond. So only her readers even saw the question. And not all the readers responded. Only some of the readers responded. And generally those who respond usually have a different opinion than those who don't. And in this case, those who responded had very strong opinions about their children, apparently. And, well, we don't really have any details here. Professional polls generally make a lot more effort to avoid biases as much as possible. Again, we don't have the details, but between those two, I would say the Newsday poll, 91% yes, is much more reliable. So, Ann Landers' results suffered from selection bias since only her readers were asked. It also has non-response bias since it included only those readers who chose to respond, and those choosing to respond usually have different opinions than those who don't. And while the details of the Newsday poll are missing, professional polls usually include some form of random selection. Selection and non-response biases would be less likely an issue.